In this video, I'm going to show you the technique of extraction. Extraction is a technique that allows you to separate separate material. It can be two liquids or two solids from each other. They have to be soluble in some kind of solvent. I have a solution here, this brown solution, that contains caffeine. Okay, so it's basically an extraction from tea, and I'm going to add that to my separatory funnel. And to make that easier, I'm going to use a funnel. Okay, so the first thing we're going to do is add this this solution containing caffeine. And when you do this, make sure before you pour it in there that the stopcock is closed. I'm going to show you later on what happens if that remains open. Okay, so one of the first rules of extraction is that when you collect your aqueous layer and your organic layer, you never want to throw any solutions away until you've isolated your, in this case, caffeine, but whatever material you're extracting. So don't throw any solutions away, and then you can continue with the extraction. So at this point, we want to add our solvent. This is an aqueous solution, and I'm going to extract this caffeine using two different organic solvents. The first one is ethyl acetate, and the density of ethyl acetate is lower than water. So what will happen is it will remain on the top of our aqueous solution. So I'm not measuring out the volume here. I'm just going to add a certain volume just to show you the technique. Okay, so I'm going to use the same funnel and pour this in there. Now, ethyl acetate and water are not miscible, meaning they don't dissolve in one another. So the technique of extraction is using a separatory funnel is we have the two solvents, and you should see roughly two layers. But if we were to just let it sit here, there's not much contact between the two layers, so we have to mix them. Now there's two different ways you can mix material using a separatory funnel. You want to grab it with, generally you want to grab a separatory funnel with two hands. I have bigger hands. This is a smaller separatory funnel. So you want to invert it and release any pressure that may have arisen. And then you can gently swirl the solution. You can swirl this for 15 or 20 seconds and release the pressure. That's one way of doing it, and the gentle mixing is very important when there's a possibility of forming an emulsion. Okay, and an emulsion I'll describe a little later, and I'll actually show you what an emulsion looks like. Or you can really shake it a couple times and release the pressure. Okay, you want to do that 3 or 4 times, and what this is doing is basically allowing the two solutions to come into contact with one another. The more surface area, the more contact, and the better transfer of caffeine to the organic layer. Okay, while this is separating, it may take a little while, but while these two layers are separating, you should label your collecting flasks. Now in this case, I have two different collecting flasks, one labeled for the organic layer and one labeled for the aqueous layer. Now it's very important that you don't label these top layer and bottom layer, because that's not very descriptive. The top layer and the bottom layer may change depending on the densities of your solvents. Okay? So organic layer, aqueous layer. Okay? When you shake it up, you'll let it sit here until the two layers separate. And you can't see it because of the ring here, but I'll pick it up so you can see the two layers. And once they have separated well enough, I'm going to put our collecting flask underneath. Now again, the aqueous layer is more dense. So the aqueous layer is more dense than ethyl acetate, so it's the bottom layer. I'm going to lower this just a little bit so we can get this over the Erlenmeyer, our collecting flask. And now you simply want to open the stopcock until you have the interface just at the level of the stopcock. When it gets to that level, you want to stop it and open this. You want to open it. You can open it fairly quickly at first, and you'll slow that down as the interface gets a little closer. Okay, so the 2 layers moving down, and again, this will narrow. The bottom layer will narrow until it gets to the entrance of the stopcock. And there, I still have a little bit. And now at this point, you want to go fairly slowly and trap that in the stopcock. Okay. Now we have our aqueous layer on the bottom. We don't want to pour the ethyl acetate through the stopcock, because we want to, if we did that, we would contaminate it with a little bit of water that's still present in the stopcock. So the top layer always goes out the top of the separatory funnel. Okay, so as you can see, some of the color was transferred to the ethyl acetate layer. Typically in an extraction like this, you're going to do 2 or 3 extractions. You'll simply have to follow your procedure, which is given to you in the lab. Okay, I'm going to repeat this procedure using dichloromethane as our solvent. Okay, so I'm going to simply pour the tea solution back in to our separatory funnel. Now, dichloromethane has a density which is larger than water. So you're going to see a bit of a difference in this extraction. So as you can see, the dichloromethane is more dense, and it simply goes straight to the bottom of the separatory funnel.